Okay, class, we're on lesson number 4, and we're going to cover intercepts. Let's take a look at this illustration we have here, which is in Portuguese. So, unless you know Portuguese, you may not understand what they're actually saying. But we can see something here, and we see an X and Y table. Okay, now it says this is a problem from an algebra book written in Portuguese. The first part of the problem is to use the table to trace a graph. See, trace o gráfico. Plotting 3 points having the numbers in the table as their coordinates, we find they lie along a line. The graph at the left shows the points and the line. Notice that the line crosses the x-axis at point 0 or 6, 0, and the y-axis and in the point 0, -3. The numbers 6 and -3 are called the x and y intercepts of the line. So if we take a look at that graph and we see those 2 points, it's crossing the x-axis at points at 6, and it's crossing the y, which is the vertical, at -3. Now, the intercepts of the line are the numbers corresponding to the points in which it crosses the coordinate axis. Now, I'd promise you that we would start graphing in a simpler fashion, and this is going to be the first step towards a simpler fashion. Now, if we know that the graph of an equation is a line, we can draw the line by using only its intercepts. We could, for example, have drawn the line in the graph above using only the points 6, 0, and 0, -3. The third point, 4, -1, isn't needed to draw the line at all. It is useful, nevertheless, as to check whether the line that we have drawn is correct. Now suppose that instead of having been given the table to the problem above, we had been given the equation of the line instead. An equation for the line in standard form is, so for this particular graph, it would have been x minus 2y is equal to 6. So, to find its intercepts of this line, we can use the fact that because each crossing point lies on one of this axis, one of its coordinates is 0. So, all we'd have to do is just go in and put 0 for x in one case, solve it, and then put 0 for y in another case and solve it, and we'd have 2 different points. So let's see. It says, for example, the x-coordinate is 0 where the graph crosses the y-axis. Okay, I know this gets a little complicated when we think about it. When the x value is 0, okay, that's where it's crossing the y-coordinate. Why? Because let's take a look here. This is our x-axis and this is our y-axis. And when x is 0, that means the value is going to be on the y-axis. Now, we don't necessarily have to remember that. We just need to know that one value has to be 0, and we'd have to find the value. And then the other value for the other variable would have to be 0 and find that value and find the 2 coordinates. But they're just kind of showing us that the x-coordinate is when it's 0, it's when it crosses the y-axis, and vice versa. When the y-coordinate is 0, it's lying on the x-axis. Okay, but don't let that confuse you. Let's stick to the math and let's figure out how to do this problem. Well, they say, well, if it's 0, and they put it in parentheses, minus 2y is equal to 6. We're able to now solve this by well, we have 0, so the x just completely goes away, and then we're going to divide by -2, and that answer would then be y is equal to -3. Now we knew that when x was 0, y was -3, which takes us all the way down to here. I don't have my black marker, so I'm not going to mark it. But let's go ahead now and say that the y-intercept is -3 when we let y is equal. Now, when y is equal to 0, well, we'd have the other half. We'd have x minus 2 times 0 is equal to 6. And that leaves us with x minus 0, so x is equal to 6. So we have 2 points here. Let me write the first point. For this one, that would have been 0, -3, and then we have the second point over here, and that would have been 6, 0, because we let y equal to 0. Now you might notice that in the past what we've been doing is creating a table using x and y values. This is a table with simply two coordinates, where x is equal to 0 and where y is equal to 0. Okay, so there's two different points, 0, -3, and 6, 0. And again, once we're able to determine these 2 points where their intercepts are, so 0, -3 is on the y-axis, and 6, 0 is on the x-axis, we would be able to draw a line and simply represent that graph and not have to do all the values that we were doing in the previous lessons and previous chapters when we were trying to solve using various values for x or y. So again, this is a simpler way of us graphing, and we have an example below here. We have graph the equation 4x plus 3y is equal to 18. Now the first thing we do is simply, you see we don't even use a table anymore. We're just going to go ahead and plug in 0. 4 times 0 plus 3y is equal to 18. 3y is equal to 18. Y is equal to 6. Okay, y, well, we divide each side by 3, and you get y is equal to 6. So that means that the y-intercept is 6. So you can just go straight to the y-intercept and say, oh, it's all the way up here. And again, I don't have my black marker right now. Let's just say we would put a point there. Maybe I should put that point because we're going to use the other point as well. So let's say I would just point. That's my y-intercept. Now let me go ahead and let y equal to 0. So I have 4x plus 3 times 0 is equal to 18. And then that would give me 4x is equal to 18. Dividing both sides by 4, x would be equal to 4.5. So now I go down here and say this is going to be, it's positive 4.5. So it's in between 4 and 5. Now I have 2 points, and I just need to connect the 2. In fact, I can connect the 2, and I can extend beyond. And in doing so, I'm giving all the answers to this particular equation that we just did, which was 4x plus 3y is equal to 18. Okay? Plotting the 2 points, connecting them in a line, we get the graph at the right. And you could check your work by simply saying, well, show me a point that I could discern, I can tell. In this case, if you look at their graph, you could see that point 3, 2, it went right through there. As you look at the other numbers, you see that they're fractional. Even when it gets to the x-axis, it's a fraction, it's 4.5. But this is the one where you say, wow, it's right on a on an integer on both the x and y values. So you can go ahead and plug those values in and determine whether or not it's the value, if your graph is right. And if you plug it in, you turn over on page 260, you'll see that the math works. It's 4 times 3 plus 3 times 2. We end up with 12 plus 6, and 12 plus 6 we know is 18, so it makes it true. Had we gotten a wrong answer, it would mean that our graph is wrong. So we need to go back, and maybe we made a mistake in our math and when we were trying to determine what the x and y intercepts are. We have another example here. Graph the equation 2y is equal to 7. Now first we want to let x equal to 0, but x does not appear in it. Okay, so what do we have to do? Well, we have to add 0 times x plus 2y is equal to 7, and that's the same as simply saying 2y is equal to 7. It's the same thing as saying, well, 2 is equal to 2, right? Well, 2 plus 0 is equal to 2 as well. Now, when we go ahead and we let x equal 0, we'll see that y is equal to 3.5. Now, the y-intercept is 3.5, and the line crosses the y-axis at 0, 3.5. Now, letting y equal 0 in either the original equation or the equation in standard form, we see that we have a false equation. We see 0 is equal to 7. This means that y could never equal 0 in the equation. Okay? We know that it cannot happen. Now think of it. If y cannot equal 0, then what does that mean? It means that it does not have an x-intercept. It never can cross the x-axis. All right, could never cross over, which means that we have a line that's parallel, all right, to the x. Because let's say if it would just had a slight angle to it, it would mean somewhere along the line it would eventually cross. No, it has to actually be parallel. It has to be a horizontal line, the same as the x-axis is a horizontal line. It has to be perfectly horizontal, perfectly parallel, and it could never cross it, because in this equation, y could never equal 0. And we see that. Mathematically we see it, but we also have to be able to represent that in the graph. In the graph it would just be a perfectly straight line. So that's a good way of showing you how this particular method of finding the x and y axis can result in something that isn't necessarily going to give you both an x and y intercept. And in this case you could see that 2y is equal to 7, y is equal to 3.5. Now stop for a minute and just take a look at that graph, and you could see that regardless of what the x value is, y is always going to be equal to 3.5, because that ultimately is the equation. Y is equal to 3.5. Always. It's always equal to 3.5. Okay, so now, it is possible for a line to not have a y-intercept. It's the same thing, it's just flipped the other way. It's now going to be something vertical. It's going to be parallel to the y-axis. In such a case, illustrated at the left, at the top of the next page, the line is parallel to the y-axis. So here we have a line, you see the green line, and this line does not have a y-intercept. Okay. Now, finally, both intercepts on a line can actually be 0. In this case, illustrated in the right hand, we see that it's just going straight through. The line goes through the origin. To graph an equation for which both intercepts are 0, we have we have to choose a second point that is on neither axis. So in other words, it's actually crossing through both, so you're not going to have two intercepts. Why? Because both intercepts are 0, 0. In that case, you just need to find another point that doesn't cross. Now you have a second point where you can now connect the two and obviously show the graph. So these are the three exceptions, in a sense, where you don't have either an x-intercept or a y-intercept, or where the intercept is actually the same point, in this case 0, 0. Okay, and if it is, then you'd still need another point. So that's the end of this lesson.